What's up, everyone? Welcome back to another Math 18A lecture, College Algebra. I put on a different shirt from last time because I wanted to look like I'm recording it on a different day. You gotta be fresh, you know what I'm saying? So today is the last lecture before spring break, and we're doing section 3.3, which is polynomial division, an important topic. So buckle up, we'll get right into it. So polynomial division. So the process actually works the same way as long division works. Regular old long division with just numbers, but polynomial division looks a bit scarier because it has x's, like variables, in your expressions here. So first thing that I want to do is just do a quick example of long division to make sure we're all on the same page. I'm sure we all know how to do it, but just to be sure. So I want to divide 123 by 4. So first I look at my first digit here. 4 doesn't go into 1, so I move to the next one. Check this whole thing. Does 4 go into 12? Yes, it does. It goes in 3 times, right? So I put my 3 up here. 4 times 3 is 12. I have to subtract that, right? 12 minus 12, well, that's just 0. I bring down my 3. Does 4 go into 3? It does not. So I put a 0 here now. And so I run out of digits here now, right? So that means that I have a remainder. I have a remainder of 3. So another way of writing this division is we could say that 123 equals 4 times 30 plus 3, right? This is kind of a non-conventional way of writing it, but it means the same thing. I divided 123 by 4 and I got 30 with 3 left over. So that means that if I multiply 4 by 30 and I add 3, I should get 123. And that's easy to verify. So just some terminology to remember. This number, 123, is called the dividend. This 4 here is the divisor. The 30, we call it the quotient. And this 3, that's my remainder. I'll write it in black because yellow is a little bit pale. But I'll underline it in yellow so we all know. Okay. So we can write this same expression, but in terms of functions of x. So let's go ahead and do that right over here. We can write f of x equals d of x times q of x plus r of x. And we call this the division algorithm. And our terms are the same thing as they were before. Your f of x is still the dividend. Your d of x is your divisor. Your q of x is the quotient. And your r of x is still your remainder. Okay, so I want to walk us through an example slowly of what it looks like when you divide a polynomial by another polynomial. So let's say we have x squared minus x minus 6 divided by x minus 3. And this will just be the first example here. Okay, so same kind of thing. Since I have two different terms here, this x and this minus 3, I want to look at the first two terms of my dividend. And so I'm thinking to myself, what do I need to multiply this first term to match up with this term, essentially? But you only need to look at the first term right here. So I have x squared here and I have x. So I'm thinking, what do I need to multiply x by to get x squared? So you think about that and you think, well, I already have x. I just need one more x if I want to get to x squared, right? So what I need to put up here is just an x. And so the next step is to multiply that out, this x times x minus 3. So multiply x times x minus 3. You have to distribute here, right? Distribute to both terms. So that gives me x squared minus 3x, right? I need to subtract that. And I would recommend putting these parentheses here because the signs can get a little bit tricky. So I'm subtracting that from what I had up here. And so what we sort of have is x squared minus x. And remember, we're only working with these first two terms so far, so like you can sort of like cut it off like that. So x squared minus x, and I'm taking away x squared minus 3x. So, and this is a side calculation here, so let's rewrite it without our parentheses. Distribute this minus sign, that's very important. I think I'll put it in red actually, distribute the minus. So minus x squared here, minus and minus becomes plus. So plus 3x. And then I need to combine any like terms that I have. So I have x squared and I have minus x squared. So those are actually going to cancel out with each other. And then I have minus x plus 3x. So that's going to give me a positive 2x here, right? So I just performed this whole subtraction and I was left with positive 2x. Now I want to bring down this minus 6. And next, I'm sort of thinking the same thing. So let me go over here. This was the first part. This was the second part. This is the third part. And then we like go down here. So next, I'm kind of thinking the same thing that I did in step 1. What do I need to multiply? Again, this x to get to 2x now. I'm always trying to match my my divisor with whatever I'm trying to divide over here. So, well, I have x already, I'm missing this 2. So what do I need to multiply x by to get 2x? Well, I just need to multiply by 2, a positive 2 actually, right? So plus 2. Okay? And so then we do the same thing as before. You multiply out by your 2. So I am running out of room here. I'm multiplying 2 by x minus 3. Distribute the 2. 2x minus 6, right? And I'm subtracting that. Minus a 2x minus 6. And so we're taking away, if I distribute this minus sign, which I think I'll just do here, minus to this one, and then the minus gets distributed to the other one too, so this becomes a plus. right? So 2x minus 2x, 0. Negative 6 plus 6, also 0. So that means that I have a remainder of 0 here. And so to write it back in our division algorithm form, we'll write f of x, which was x squared minus x minus 6, is equal to, I need my divisor next, x minus 3, and then I need my quotient, which is this up here, x plus 2, and I need to add my remainder. So in this case, our remainder was 0, but it won't always be 0, so plus remainder plus 0 here, which just equals x minus 3, x plus 2. And so because our remainder here was 0, you can notice that this is actually just the factored version of our original polynomial. And so this was kind of the technique that I was referring to last lecture, is how you can kind of get around factoring, just using polynomial division. But the catch is you have to know one of the factors, or one of the zeros. So let's pretend that I told you to factor this expression that we had, x squared minus x minus 6. It's relatively easy to factor, so maybe you wouldn't do this here, but you could notice, like, you need to find one value of x that will, like, set your equation to 0. And so what we'll see in, like, a future chapter is you get a bunch of possibilities of zeros, and you kind of just plug them in to check and see which one gives you 0. So, like, let's say that we notice, what happens if I try x equals 3? If I plug in 3 here, 3 squared minus 3 minus 6 equals 9 minus 3 minus 6. So 9 minus 3, that's 6. Minus 6 is 0. So if you can guess a 0, namely here x equals 3, then you know that x minus 3 is a factor of my original polynomial. And then you can use division like we did here to find that the other factor has to be x plus 2. Not that handy in quadratic situations probably, but when you get to higher degree polynomials, that's kind of the only method that we have of actually factoring it sometimes. So yeah, just keep this in mind for future lectures. Okay, so this example was a little bit simpler. I hope it helps us build our understanding of how dividing is related to factoring and everything like that. So the next example I want to go through is a little bit more challenging. So I want to divide x cubed minus 27 by x squared minus 1. So these are no longer linear, right? Or this divisor is no longer linear. It has this x squared, so that's going to change things up for us a little bit. And we're supposed to write our answer in the form f of x over d of x equals q of x plus r of x over d of x. So this is a slightly different version of our division algorithm. Let's go back to that for a minute here. So notice that if I just divide my entire equation by this d of x, then I'll end up in the form that we're supposed to write our answer in. So dividing everything by d of x, it canceled out on this term. So I'm left with just q of x and then plus the remainder over the divisor here. And so this is just another way of writing this expression here. It kind of makes a little bit more sense when you're talking about dividing, because you're asking, what is this divided by this? So what is f of x divided by d of x? Well, that equals my quotient plus my remainder out of the divisor. So that's how we're going to be writing our answer. So let's set up our expression under the dividing bar. So x cubed first, right? You want to notice that we're missing a bunch of terms in the middle here, right? I have x cubed. I don't have x squared or x in this expression at all, but I do want to write them down. So I'm going to write plus 0x squared plus 0x and then minus 27. Just so we have like a placeholder for them. Even though they aren't in our expression, we want to be careful about lining everything up. And hopefully you'll agree that this is the same as this, right? And we're dividing that by x squared. Let me actually write that the same way. Plus 0x. So I need a little bit more space here. X squared plus 0x. I'm missing that x term. And then minus 1. So we have 3 terms here. So I'm going to want to look at 3 terms here as well. And I'll cut myself off like here. Okay, so I will try to annotate on this side. And I'll try to keep it small enough so I can fit everything. So first, I'm looking at these 2 things. I'm comparing them, these 2 things underlined in red. And I'm looking at the first term specifically, this x squared and this x cubed. And I want to think, what do I multiply my x squared by to get x cubed? To get x cubed. So I have x squared, I want x cubed, I'm missing 1 factor of x. So that's what I need to multiply this by to get to x cubed. So put an x up here. We align it right next to this line here. And so now I need to do the multiplication. I need to multiply x times what I have here, my divisor. Okay, so let's distribute everything to all of the terms here. So this gives me x cubed plus 0x squared, right? Because I had 0x, I'm multiplying that by x, so I'm still going to have 0x squared now. And then minus 1 times x, so that's going to give me minus x. Okay, so then we subtract this that we just calculated. Subtract that. So we line it up. X cubed plus 0x squared minus x. Copy it down, put parentheses around it, and subtract it. Okay, so let's do that down here. I have x cubed plus 0x squared plus 0x minus x cubed. Sorry, that's ugly. Cubed plus 0x squared minus x. I have to distribute my minus sign again here. So I have x cubed plus 0x squared. I'm just copying the first part here for now. And then minus x cubed. Minus plus, it's just 0, so it doesn't matter if it's minus or plus, but I'll distribute it for consistency. 0x squared. Minus and minus becomes a plus. Okay, so my x cubed and my negative x cubed here, those cancel. 0x squared, 0x squared, still 0. And then 0x plus x, so I just end up with plus x, positive x, right? So everything essentially canceled out except for an x that I have left over here. And we line that up in our x column, right? So next, I need to bring down my minus 27. And so now that I've reached this point, with this x minus 27 left over, notice that I can't multiply this, my divisor, by anything to get to x minus 27 because the degree here is lower than the degree here. So that means that I'm done dividing now. So this is going to be my remainder. So if I'm writing my answer in this form, I have, so f of x was x cubed minus 27 over d of x, my divisor, x squared minus 1, equals q of x. Q is the quotient, and that's always going to be your answer up here on top of the dividing bar. So just x. And then plus your remainder over your divisor. So plus, my remainder is this. So x minus 27 over, again, my d of x, my divisor here, x squared minus 1. So this would be my final answer here. And let me just make a note of how you know when to stop dividing. You know you're done. You're done dividing when you obtain a result with degree smaller than the degree of the divisor. Let's write degree of your divisor d of x. Okay, so I know this does seem a bit tedious. It is a lot of work for, it doesn't seem like it's getting you that much, but you will definitely see a polynomial long division problem on the final. So you do need to know how to do it, at least for that purpose. There's also a different method called synthetic division, which I think I'll show at the end of this video. And it's a bit of a shortcut, but it doesn't work all the time. Polynomial division works all the time, but synthetic division, it doesn't work if you have nonlinear divisors, like this x squared minus 1. It wouldn't work here. It wouldn't work on this problem either because of this nonlinear divisor, so yeah, but it is a bit quicker, so I'll show you guys that after this. Okay, so let's do an example from the final. Use long division to divide f of x equals 2x cubed minus 5x squared plus 7x plus 1 by d of x equals x squared minus x plus 2x. And we're going to be writing our answer in the form that we had last time. F of x over d of x equals q of x plus r of x over d of x. Okay, so I'll set up my problem again. 2x cubed minus 5x squared plus 7x plus 1 divided by x squared minus x plus 2. And notice I'm not missing any terms in between. This time I have one of each degree for both of them, both my f of x and my d of x, so I don't need to put any plus 0x plus 0x squared or anything here. And I will annotate over here. Okay, so again, first things first, ask myself, what do I need to multiply this x squared by to get 2x cubed. And remember, we have three terms here. So we draw a little cutoff line here for now, because that's where we're going to end up first. And so looking at our first terms, that's what we always start with. So I'm multiplying something by x squared to get to 2x cubed. So I'm missing this factor of 2, and I'm also missing an x, right? I have x squared, I need x cubed, and I need a 2. So what I need to multiply by is 2x. And we line that up in our x column. And then we do the multiplication. Multiply 2x times x squared minus x plus 2. Distribute to all of your terms so that you have 2x times x squared. It's going to give me the 2x cubed that I was looking for. 2x times minus x, a minus 2x squared. 2x times 2. So that's going to give me plus 4x. Okay? Next, I want to subtract that. Subtract this. Okay, so I'll line it up. 2x cubed minus 2x squared plus 4x. Throw parentheses on it and subtract. And I've been doing side calculations to do that, but if you just distribute your minus and you're careful about it, you can do it like in the column still because it's already lined up for you kind of nicely. So 2x cubed minus 2x cubed, that should cancel out. So I'll have a 0 over here. Negative, distribute that to this term. That's going to give me plus 2x squared. So I have minus 5x squared and I have plus 2x squared. So that's going to give me a minus 3x squared. Carefully distributing again, the minus comes over to this 4x, so I have minus 4x, and I have plus 7x, so that's going to give me plus 3x. Right? And feel free to always do a side calculation if you want to. It's kind of nicely lined up here, so I've gotten used to doing it this way, but just to be safe, you can always do that. So next, we want to bring down this 1 here. So it's plus 1. You take the sign with you. Okay, so I checked this. It has the same degree as this. This x squared and this x squared, they're both degree 2. So I'm not quite done yet. It has to be smaller. This one has to be smaller degree to know that I'm done dividing. So I have another step to do. So let's check again. We're looking at our first terms here. Again. So next I want to do, what do I multiply by? To get negative 3x squared. Well, the x squareds are already the same. So all I'm missing is this factor of negative 3. So I need to multiply by negative 3. So I write my minus 3 up here, negative 3, right? And then next we want to do the multiplication. Negative 3 times x squared minus x plus 2 equals negative 3x squared, distributing that minus 3, plus 3x, negative times negative becomes positive, negative 3 plus 2, so that's going to give me a minus 6. And then I subtract once again. So it's following the same steps each time. The thing that changes is what you're multiplying by. So let's write this part down. Minus 3x squared plus 3x minus 6. Throw parentheses around it, subtract it. And so, distributing this minus again, this will give me plus 3x squared. Cancels with this minus 3x squared. And that should always happen. Your first term should always cancel so that you proceed with the division correctly. Distributing this minus to the 3x here, I get minus 3x and I get plus 3x. So these ones cancel as well. And then finally I have minus distributing to my minus 6. So I have plus 6 and I have plus 1. So I have plus 7. Which you don't really need the plus there. So I guess I'll just write 7 actually. And so then checking this, the degree on this, there's no x here, right? So my degree is actually 0 here. And my degree here is 2. So this is now less than, the degree here is less than the degree on my divisor. So that means that this is my remainder. And so all we have left to do is write our answer in this form. So let me go to another page. My f of x was 2x cubed minus 5x squared plus 7x plus 1 divided by, the divisor was x squared minus x plus 2. And that equals my quotient, which is always on top of my bar here. So 2x minus 3 plus the remainder, 7, over the divisor. So plus 7 over the divisor, same thing as over here, x squared minus x plus 2. So this would be your final answer here, written in the form that they've asked us to write it in. Okay, so now I would like to cover synthetic division. A bit of a shortcut to polynomial division, but note, you must have a divisor of the form x minus k. So no, x squared is nothing like nonlinear, right? And so your book has it defined for a cubic, so we'll start with that. Let's say you have your f of x is ax cubed plus bx squared plus cx plus d. And your divisor is x minus k. We'll just keep it in variables for now, and then I'll show an example with numbers. So what you want to do is take your coefficients, this a, b, c, and d, and sort of just set them up, like leaving some room in between. And then you kind of draw a reverse like dividing bar, and leaving a whole row here open so you can fill things in. And then you write your, whatever your k is here on the outside. So k like this. And then it's another algorithm style thing. So the thing to note is if you're going downward, you add. If you're going diagonally, you multiply. So first things first, you have to bring down this a. There's nothing to add here, so you can just bring it down. And then we're going to this entry spot next. So here we have to multiply, and you multiply k times whatever's on the bottom here. So that'll give me k times a. And then going downward again, sort of like this, you have to add. So b plus k times a. And then going up to this next entry's place, you would multiply by k again, and continue doing it like this, until you end up with a number here, and this would be your remainder. And whatever you end up with here, They'll just be coefficients, but they tell you what your new polynomial looks like after you've divided by this factor of k. So this would be your quotient here, the coefficient specifically. So now I'll go through an example doing synthetic division on a polynomial. And notice we have this nice linear factor, so that means we can apply synthetic division. So we want to divide 10x to the fourth minus 50x cubed minus 800 by x minus 6. So I take my coefficients again, right? Each of these. And first, you want to notice that we're missing terms again, right? I don't have x squared and I don't have x, but I have this constant term, so I need to put 0x squared and 0x, and I need to keep these coefficients when I put them in my box thing. So let's set up our box. I take the coefficients, 10, negative 50. For the x squared, I put 0. For the x, I put 0. And for the last one, I put minus 800. And make sure that you have your polynomial in standard form, or what do you call it? General form, I believe, where you have descending order. Like this is the highest powers first, and then followed by the next highest, next highest, next highest, right? So you have to write it that way. And then I draw my little division bar thing. I put k on the outside here. So that's going to be positive 6 because it's x minus k. So always take the reverse sign, the opposite sign, right? And so then the first thing that I'm doing, I go downward. Bring this 10 down. There's nothing to add. Bring the 10 down here. Next, I move diagonally. And to do that, I have to multiply, right? So this first diagonal part here, I'm going to get that from doing 6 times 10. You multiply the k by whatever's down here. So 6 times 10 is 60. I have to go down as my next move, so that means I have to add, add here. So negative 50 plus 60, it's going to give me positive 10 once again. My next move is diagonal, and I multiply again. So to get this answer, I do 6 times 10 once again. So 60. My next move is down. And whenever I move downward, I have to add. 0 plus 60 is 60. My next move is diagonally. So I have to multiply again. 60 times 6, my k on the outside here. 60 times 6 is 360. My last, or not quite last move, but I have to go downward again, adding these. So 0 plus 360 is 360. And then finally, diagonally, I'm going multiplying this 360 by 6. Oh gosh, I hope I know what that is. So let me write it like this. 360 times 6. So that's going to give me 0 here, 36 carrying the 3, 18, 19, 20, 21, so 2160. And then finally, my last move will be downward. So 2160 minus 800, that's going to be 1360, I believe. And so this is my remainder here. And these coefficients will determine what my quotient looks like. So let me make one more page here. My quotient q of x. All I have to do is pull these coefficients right off, not including the remainder. And my degree goes down by 1 since I divided by a linear factor. So this is now my x cubed term, my x squared term, my x term, and my constant term. So pulling the coefficients, 10x cubed, right? Bringing my degree down by 1. And then plus 10x squared. Plus 60x. And then finally the constant term plus 360. So that's my q of x. And then my remainder, 1360. So if I wanted to write my answer in the usual form that we do, like this f of x over d of x, so 10x to the 4th plus 50, or sorry, minus 50x cubed. So minus 50x cubed, and then minus 800 over d of x, my divisor, x minus 6, equals q of x. So this whole polynomial that I have now and then plus r of x over d of x. So r of x was this 1360 like I had, and then over d of x. So plus 1360 over my d of x, x minus 6. So you can see that it is a bit of a shortcut. It's less, it just seems less in depth on each step because it's simplified by pulling the coefficients off and just working with adding and multiplying. So yeah, that's kind of a nice way to do division with linear divisors. One final thing to be careful about is when you're writing your q of x with your coefficients here that we pulled off of our synthetic division like diagram. If you have a negative on any of these, you have to take the sign with you. So if I had if this was negative 60 instead, I would put minus 60x here. These all happen to be positive, so it's plus everything here, but yeah, just keep that in mind. If you do end up with a minus any coefficient down here, take that with you. Okay, and that's about all I wanted to cover today, so happy spring break, everyone. Enjoy your week off. Catch ya in a couple weeks.